Hello, ladies and gentlemen of Algebra 2. This is 10-4, talking about common logs and natural logs. We talked a little bit about log functions already, so you should know some of the properties going with that. Now we're going to talk about two of the bigger logs, so we'll talk about common logs and natural logs. So we're going to solve some exponential equations with common and natural logarithms. So let's kind of get ready. Using a calculator, evaluate each expression to 4 decimal places. Notice something, guys, that there's no number down there. Okay, usually you have log base, 7 to the 4th or something like that, where there's a number here. There's no number here. When there's no number there, we assume, okay, we just kind of call it log base 10. Okay, we use base 10 because 10 is kind of our base number for everything. We count 1 to 10, and then we start over at 11. So that would be kind of what the equivalent of log 3 is be log base 10 of 3. So if I put that into a calculator, I'm going to get 0.47712. That's going to be my answer. So over here, log base 2, this is saying, once again, log base 10 of 0.2. So when you do that, that's going to be a negative answer, 0.6989. And on some level, if you're understanding kind of how logs work, I'm hoping this makes sense. This is saying, what exponent do I put on x to get? Do I put on 10 to get 3? What exponent do I put on 10 to get 0.2? Well, it should make sense that it's a decimal. And it should make sense that that's a fraction, because that's literally saying, what exponent do I put on 10 to get 1/5? So it should be a negative exponent. So realize that that's kind of the relationship we're talking about here. So on calculus, what you're dealing with is these two buttons right here. All right, so when you're looking at log and natural log, okay, this would be considered common log. And this is going to be considered your natural log. So that's what you're dealing with right there. Okay, so on the calculators, here's where they're located. All right, on these calculators, it's a little bit tougher to find, but it's right here. All right, so you have to push Control and then E and 10. So E and 10, that's how that works with logs and natural logs, is that they work with 10 and with E. So I'm hoping that kind of makes sense here, and it will more by the time we're done. So lastly, the most popular one, log and natural log, are going to be right there. So when you say find the natural log of these things, that's where we're looking right there. All right, so let's think back here. So figure out what x is. 3 of x equals 27. Well, 3 to the first is 3. 3 squared is 9. 3 to the third is 27. So 3 to the x, 27 can be rewritten as 3 to the third. So by taking care of that, x equals 3. All right, so now that would be my answer. All right, but it doesn't always work out perfectly, okay? It's a little harder to figure out what my answer is going to be. We have to keep in mind kind of what we're dealing with. And so you're looking for an exponent. So that's kind of where log. So you want to take a logarithm of both sides. All right, so 3 to the x, 3 to the x is going to be equal to 11. So, like I said before, 3 to the first is 3, 3 squared is 9, 3 to the third is 27. So we're nowhere near 11. Okay, 11 is close to 3 squared, but we're nowhere near that. So what we do is we take the common log of both sides. So what I'm going to do is take the log of 3x, 3 to the x, equals the log of 11. Now that I've taken that to both sides, I'm going to use the property that we learned before, and I'm going to take this and bring this out front. So I'm going to have x times the log of 3 equals the log of 11. okay? So now what I do with that then is this. Log of 3 is an actual number. Log of 11 is an actual number. So log of 3 is going to be 0.4771, and the log of 11 is going to be 1.0413. So now, just like every other algebra problem, solve it. So divide. So my answer becomes 2.1826. And then on some level, I'm hoping that makes sense because it should be a little bit more than 2. The exponent I put on 3 to get 11 should be a little bit bigger than 2 because 2 is 9. So that's kind of what I'm dealing with here. That's what I'm doing. I'm taking natural logs to solve. So 6x equals 42. So, 6 to the first is 6. 6 squared is 36. 6 to the third is going to be 216. So I'm hoping for an answer, probably a little bit bigger than 2 again. But it's not going to be exact. So here's where I have to use log. So I'm going to take log of 6 to the x equals log of 42. So then this comes out front, log of 6, log of 42. So then to solve, divide by log of 6. And you have to kind of imagine, you put these numbers in a calculator, you're going to get a decimal. So my answer is going to be log of 42 over the log of 6. So log of 42 is going to be 1.6232. The log of 6, is going to be 0.7781. So when I divide those two, I get 2.086. There's my answer. And on some level, I hope that makes sense. You're going a little bit bigger than 2 to get to 42. That would be the exponent you're putting on 6 to get that number. So natural logs are basically just regular logs with a base of e. So natural log of e to the x would equal 4. All right, so we call this a natural log. Looks like ln. N means your log is natural. So e has a value, much like pi has a value. Pi keeps going on forever. E keeps going on forever. So what this is saying is you have a log with base of e. All right, I know this is the first time you guys have seen e. E is a naturally occurring number. You can look it up on your own just to kind of get some background on it, and it might help you understand a little bit better. So let's kind of play around with this and get. So your natural log button is right here, or I showed you guys on the other one, so you can go back and look. Natural log and e are pretty much right next to each other usually. So if I go e to the second, that's going to be 7.389. If I go e to the negative 1.3, that's going to be 0.2725. And if I go natural log of 4, it's going to be 1.3863. If I go log of 0.05, it's going to be negative 2.99, basically negative 3. All right, so remember, natural log basically means log base e. So we just kind of shorten it to that. Now, a couple things to remember. Here's the graph of e, depending on what you raise it to. Notice it's an exponential. And then log of x is a perfect inverse to the natural base. So this one's e to the x. This one here is going to be the natural log of x. Notice they're perfect mirrors going across the y equals x line. All right, so they perfectly undo each other. Okay, so here what this is saying is they want a logarithmic equation or they want something equivalent. So what I'm going to do is kind of undo that by using my natural log. So if I have e to the x equals 5, I'm going to take the natural log of both sides, And then I'm going to bring this out front. So I'm going to have x times log base e equals log base to the 5. Now remember something. This is going to be 1. Log and e cancel each other out and you get 1. So x is going to be equal to the log of 5, which is going to be 1.6094. So over here, the log of x on this one, so what I want to do is raise both sides to that. 0.6931. So that's going to cancel out. So x is going to be approximately equal to e to the 0.6931. So x is going to be equal to approximately 2. All right, I get 1.9999, so I call it 2. And you can even test, what is the natural log of 2? What's that equal? Well, that's going to equal 0.6931, which is pretty close to what you got there. So in order to solve, what we want to do is inverse operations. All right, so that's what we've been doing all the time to solve. Addition, subtraction, they're inverses. All right, division, multiplication, they're inverses. We do the opposite of what's there. We call that inverse operations. So we have square roots and we have squares. Logs and exponentials are inverses. E of x and natural log of x are both inverses. So we can use those to solve. So let's kind of take a look at what I'm doing here. I'm trying to figure out what x is. X is stuck inside this exponent for e. So here's what I want to do. I want to add 7. 5 times e to the negative x equals 9. Okay, so then I'm going to divide by 5. Okay, so you're dividing both by 5, so you're going to have, so you're going to have e to the negative x equaling 9 over 5, which is going to be 1.8. So now what you want to do is you want to take the log of both sides, and you'll move this out front, so you'll have negative x. The log and the e cancel out, so you have the natural log of 1.8. Natural log of 1.8 is going to be 0.5877, or 78 technically if you're rounded. So x will be equal to negative 0.5878. There's my answer. All right, so that's that one. So here we're looking at add 9 to both sides. So 4 times e to the negative x would equal 7. Divide by 4, divide by 4. E to the negative x equals 1 3/4, or 1.75. So take your natural log. I'll move it up here. So I'm going to have negative x equals the natural log of 1.75. So negative x equals 0.5596. So x is going to equal negative 0.5596. There's my answer. All right, last problem. So continuous compound interest looks like this. P is your principal amount. R is going to be your rate. T is going to be your time. Okay, time, and that's usually in years. So what we're looking at is this. So you've got an initial rate of $1,000 times E raised to the R times T. So here's my rate. So 2.5% becomes 0.025. And that's 10 years, so that's going to be times 10. So when I'm looking at this, I'm just going to multiply it all out. So E raised 0.025 times 10 is going to give me 0.25. So when I do that, I'm going to get 1,000 times 1.2840. So that means that's going to be 1,284.02. There's my answer. How long will it take to reach $1,500? That is where you're going to get a little bit trickier. So you're still going to have this. You're still going to have 0.025, except now it's going to be multiplied by t, and it's going to be equal to 1,500. So now I need to solve it. So I need to divide by 1,000. So that cancels out. E to the 0.025t. 1,500 divided by 1,000 is just going to be 1.5. So now I want to take my natural log and work with that. So I'm going to do natural log, natural log. So I'm going to bring this out front. So I'm going to have 0.025t equals the natural log of 1.5. So the natural log of 1.5. Then I'm going to divide that by 0.025. This ends up being 0.4055 divided by 0.025. So T is going to be equal to 16.22, rounded. So a little over 16 years to get up to $1,500. Notice I'm using the same property a lot. I'm taking the natural log of both sides or the common log of both sides and solving it from there. Come talk to me with the questions. Make sure you find those buttons on a calculator, and we'll talk to you soon.